Dmitriy will share his experience how to use LiDAR in a difficult condition in the mountains.
Okay, is it visible to everybody? My name is Dmitriy Predein. Let's start the presentation. So first of all, I want to tell you that the region where we was working, it is in northwestern Georgia, and it is a very hard and mountainous relief. So the main task of our project was to find the most suitable location to lay the pipeline leading to hydroelectric power plant, which was located down the river. So, of course, generally it is desirable to find some open areas in order to avoid tree cutting, utilities relocation. I mean, the factors which may increase the costs of construction works or slow down the construction works. So, regarding our equipment, we had two drones from TOPODRONE. First of them, it's DJI Mavic 2 Pro PPK and TOPODRONE LiDAR 100 Lite plus DJI Matrix 300 RTK. Central access line, which you can see on this slide, was given to us from our contractor. It is the central line. It's line of the interest of our contractor. The total length of this area was 6 kilometers. The corridor width 200 meters, and the total area was 120 hectares. As you can see on this slide, our deadline was very short. We should do all the shooting in one day, all the survey. So it was like a bit hard for us, but let's go forward. It is mission planning. All of the missions were created and implemented using the UGCS Pro software. Of course, in a mode of the terrain following, because in Georgia, it is completely impossible to fly without this mode because the terrain doesn't give you an option to fly like on the flat area. All the time, if you are using the LiDAR, you need to fly and follow the terrain because the height between the surface and the LiDAR should be permanent. So we created 3 LiDAR missions in total, including 2 linear missions, 3 kilometers each, and 1 aerial mission in the start point of this route. And also we had 4 Mavic 2 Pro missions for creating the Orthomosaic. Unfortunately, we were not able to manage to go for a preliminary site check because each time we tried, the weather conditions interfered. And there was less and less time before the shooting. So when we saw a satisfactory weather forecast, it was decided to go and shoot right away. Of course, taking into account that we didn't know the site conditions, some of the missions that you can see on this slide were edited and changed directly in the fields. And more that I wanted to say, the very important problem for aerial survey in Georgia is mountains. Consequently, total and permanent loss of the signal between the drone and remote controller. So during the flight, you will not have any FPV picture from the drone, or you cannot interrupt the mission or do something. That's why all of the mission were prepared with the continue flight option, which means that the drone, when the drone will lose the signal, it won't interrupt the mission and it will just continue, finish, and only after that, the drone will return to home for landing. But for us, it's like the working situation, nothing unusual. Like, me and my colleague, we are working together. And when we lose the signal between the drone and remote controller, we're just starting to smoke. And when we are reaching the signal from drone, we're just finishing. And it may be like 5 cigarettes, I don't know, maybe more, maybe less. So it's like very stressful. We started the aerial survey early morning. The decision was very simple. Due to lack of the sunlight, it was very important to complete the aerial photo survey and only after that perform the aerial LiDAR scanning. By the way, sun practically did not show out from behind of the mountain, so only half of the gorge was illuminated during our flights. Along the whole central axis, we prepared the ground control points. Of course, where it was accessible, because there was plenty of places where it was simply impossible to go down by foot. And only the first mission was completed successfully, and the weather conditions were good, no wind, no rain, and surprisingly, we didn't lose the signal for this mission. But despite this fact, already for the second flight, the wind rose, and I had to split up the second mission on the two parts because battery charge wasn't enough. Approximately at 5 p.m., we finished all the APS, aerial photo survey, and continued the ALS works. So everybody mentioned today that night shooting is just great. The only I can say, yes, of course, because this opportunity is just, great. As Mr. Simeon mentioned, nobody will call you, nobody will interrupt or disturb. It's just great. It's just great. But sometimes, like now, it is also risky when at night, when you fly on a flat surface is okay. But when at night you are flying in mountains, and you understand that when you don't have a signal during the day and accidentally the drone will crash, like it is stressful, but at least you can go forward and just try to find it. At night, you have no chance. I will repeat. Luckily for us, LiDAR doesn't depend on illumination at all, and it allows to fly. That's great. So that's what we did the first day when we arrived. We arrived one day ago, and it was already at the evening. We had a hope that we will do some site inspection at least in the evening, but it was already dark. And instead of wasting time, we just made a first LiDAR scanning. So we came to the start point, opened the M300, and just did it. So the next day, when we finalized the aerial photo survey, the first 3 kilometers of this gorge were already covered since last day. And of course, it was a bit scary and risky to fly at night, but equipment gives you this opportunity, and it's okay. The second mission that we did, it was the second section of this gorge. And when I started the mission, drone lost the signal in 2 or 3 minutes after it, but surprisingly, we reached the signal after 5 minutes, plus minus approximately. As I found out later, there was a huge rock in the most problematic place on the road, in the middle. It wasn't visible from our road where we were driving car. The drone was trying to avoid the crash with this rock. And after maybe 5-7 minutes, it went to the landing in RTH. So we were very glad about it. So I did the flight mission and made the second try. And this time it was okay. We completed 2 sections, totally 6 kilometers length. And on our way back, we stopped on the start point for another 30 minutes to scan a river delta. It was the last LiDAR mission for this day. Once we finalized the survey, let's start the processing. I prefer to start with the image data. So we performed 4 flights, approximately 1.6 kilometers each, with longitudinal overlap 80% and cross overlap 60%. It's like the most usual overlap for us in such areas. Only when we are flying in very dense forestry, I'm increasing the cross overlap from 60 to 70, maybe more sometimes. So on average, each flight dataset contains from 400 to 500 images. Processing was carried out on RINEX files obtained from the reference networks of base stations and on Georgian quasar geoid since EGM 2008 gives a very large mistake on z-axis coordinates. The altitude won't be correct if we will use the standard geoid. And also, I forget to tell you that we are not using now we are not using the base stations, GPS, because we have a pretty good reference network. We are just going to the site, directly flying, And after that, I'm just downloading the RNX files, and this is it. We are good to go, and we are starting the processing steps. So all images were processed in TOPODRONE software in just a couple of mouse clicks using batch processing. It was very comfortable and very fast. High precision photo centers were calculated for entire volume of images taken with the TOPODRONE Mavic 2 Pro. The whole data set was separated on 4 blocks, 2 flights per one section of the site. Again, we've used the batch processing for time economy, while edges of metashape was aligning the images. Trajectories and point clouds were being calculated in TOPOLIDAR. It's like you're working and you're doing simultaneously all the data sets that you have. They are all the time in process. Of course, the accuracy was different on the section areas, but first of all, the lighting changed quickly, and the surface on which the control points were created was far from ideal. It's like big stones and slope and so on, and forestry. So, but still the quality, the accuracy of the image centers was not more than 3 centimeters, and the geotagging accuracy was not more than 2.7 centimeters. So I think that the accuracy is more than acceptable. Once we get dense point clouds from TOPOLIDAR, it is possible to continue post-processing in LiDAR 360. First of all, main task, what was requested by the contractor? First of all, unite 3-point clouds to get a general view. Verify that the z-axis accuracy values are correct. Classify the point cloud to select ground layer. Produce the surface contour lines with a step of 15 meters. And extract the set of points in CSV format with a step 15, 10, 5, and 3 meters. Let's proceed step by step. First, uniting the point clouds. After processing, we obtain a point cloud in LAS format. So each cloud is being processed separately. I didn't edit in my presentation like step-by-step processing. I give you the general view, the 3-point clouds, which are already united. On this picture, you can check the density of the vegetation and the slope in this gorge. And of course, I have added the accuracy report, which I generated in LiDAR 360 software. This data was calculated from the raw point cloud without any manipulating with the points or something. It's like, it is what it is. However, beautiful point cloud isn't the final step. The main checking, which should be produced before any further processing and manipulations, is an accuracy control, which you can see here. And after that, we should check the profile view. So as you've seen, the vegetation in this gorge is very dense. And in some places on the slope, it wasn't possible to go down by foot. And that was one of the reasons why we weren't able to take ground control points all over the central line. So for this step, we need the profile view function. And let's check the point cloud. It is very interesting to test the penetrating power of the LiDAR, in particular, where the laser beams able to break through the crowns of trees and get to the surface of the earth, because otherwise the measurements taken won't be accurate. So as you can see on this picture, we can see the complete tree structure, for example, here. And for example, here. First of all, the ground layer was reached, as we can see on these 2 pictures. And this one, I like it very much because maybe you can use it for the forestry research. We had Evgeny Lopatin who was talking about it. And on the bottom picture, you can see the bridge profile with the bridge structure and the slopes and the river. So let's continue to the next step of the processing. Next step is classification of the point cloud. And the main task, as I told on the first slide, is to get a proper ground layer. It's very easy and it is very fast. Using the classify ground points function, we get an extracted surface layer from the whole point cloud without vegetation, buildings, and etc. But to be sure that the ground layer doesn't contain other points, for example, maybe from bushes or from grass or some big stones which were on the area. First, we should prepare the DEM and to manually check everything in profile view. So all the points and all the point cloud was checked manually in the profile view. And there were some points which doesn't belong to ground layer. You just reclassify to maybe low vegetation or, I don't know, medium, high vegetation and so on. Maybe it was just noise. It is also possible. So after we got a proper surface layer, it is possible to generate the surface contour lines. As you can see here, the contour lines are generated, and it is also very comfortable for me because, I don't know to process something slowly. I like automatical modes and do it fast. And this contour lines was generated in one mouse click. It's just excellent. I don't know, great. So the survey of section with a length 6 kilometers and total area 120 hectares was completed in one day, only in one day. Even when I told you that the first LiDAR mission was performed on the last day at the evening, there was no problem to perform it in this day after this small aerial mission for the river delta. It was possible to perform another one. As I already told you, the night condition is not a problem anymore. What I want to say in a conclusion, I will just show you some pretty photos. And as a result of this project, the operation of equipment in conditions of a large height difference, and height difference was from starting point to the end point 640 meters, the difference. Loss of communication between the drone and RC and the absence of internet signal is absolutely fault tolerant. Also, processing and preparation of received data, 2 working days. 1 day for collecting all the data and 1 day for processing all the data. The accuracy has been confirmed, and all data has been verified and accepted by the contractor. At the moment of this presentation, the project is totally fully completed. Thank you for your attention. If you have any question, please do not hesitate to ask me. I will try to answer.
Dmitry, thank you for a very beautiful presentation. It's amazing job which you made, and it's amazing altitude of your flights and very difficult terrain and very difficult area for your flight. What do you think? Is it stable to use LiDAR in the mountains?
No, Maxim, I think that the only equipment that you can use in the mountains is LiDAR, because since we have a big slopes, since we have a dense forestry and very hard relief, the only equipment that may be used is only the LiDAR, because photogrammetry tool will not be acceptable for this kind of works. I think so. We can use photo camera only for visualization or colorizing the point cloud.
And what do you think, if RTK mode of survey, is it possible to use it?
No way. You need to have the connection between drone and remote controller. You need to have a connection with the base station, and also you need an internet connection. But for example, for the second mission, which was edited, we had no signal between drone and RC. We had no internet connection and even a GSM signal.
Another one question, and it was said that it was a great presentation, and you told that you told us that there were no GPS signal. So did you use GCP or not, or did you use GCP only for photogrammetry?
No, I was using the GCPs until we had a GPS signal. So as I told you, I can show you even. On this picture, it may be visible. I will zoom it. Oh, sorry. We can just delete it. So the GPS signal and locating the GCP points it was available only until for maybe this line. because after that, there is no internet, GSM signal, so the GPS it won't be possible to use it.
And how long would it take you to accomplish this work if you use common technology, common like total station or GPS?
The service specialist from the contractor side was with my team on this project, and I was wondering the same question. He told me that approximately 2 weeks.
Approximately 2 weeks. And you made...
we completed everything in the field, collecting the data in 1 day.
1 day. Whew. Huge difference, I think. And a huge... Yes, and it's a great example of LiDAR survey. It's amazing, and I would ask you if you could share this data set for blog post. And if you create a blog post, we can create a good blog post in our website. Thank you, Dmitry, for your good presentation.